In this video, we'll continue to work examples over identities. So we're going to keep simplifying expression given the information above here. Again, you need to memorize all of these. See the previous video, though, to help with the bottom 9. All right, so this first example, what we're looking is to simplify it as much as possible. So I'm going to keep my equals. Make sure you're using equals here. I have tons of students that are all over the place. You can't be that way. It's got to make sense going across left to right. So I'm going to replace my tangent with a sine over cosine. All right, it's the first thing we can do. And then we're going to times that by cosine, and we can see that those two cosines are going to cancel, leaving me with just a sine. The reason we're doing this is you guys are headed towards Calc 1. It's a lot easier to do calc things on that than it is the beginning expression. That's the whole point. All right, let's take a look at b. So you can see b here, the 1 minus cosine squared is sine squared. So I'm going to go ahead and replace that. This is sine squared theta over cosine squared theta. Now that becomes, sine over cosine is tangent, so it just becomes tangent squared theta. So these are pretty straightforward. Just getting used to simplifying these in a simple way. We're going to build up to some pretty complicated problems towards the end. All right, cosine, cosecant. Okay, I'm going to leave cosine, and I'm going to change cosecant to 1 over sine. Right? This cosine is really just over 1. We can think about it that way. So if we multiply straight across there, I get cosine theta over sine theta. And that's actually cosine over sine. That is cotangent. So we got it simplified all the way down to that. All right. So a good rule of thumb, if you haven't noticed, we're changing everything to sines and cosines. Okay, so this one, we're just going to have complicated, a big fraction in a fraction, but that's okay. Sine, I'm going to change this just to help us out, is sine theta over 1 times, I just wanted to make it look all nice, and then secant is 1 over cosine theta, and then tangent on the bottom is sine theta. Actually, let's leave it. You can see what's going to happen. I could have changed it, but I can kind of see what's going to happen on top. Okay, on top we're going to get sine theta over cosine theta. And then on the bottom is just tangent. And we can see that this is going to be a tangent over a tangent. And that's just a 1. So that complicated expression there is actually the same thing as 1. And that's why we're doing this, because doing calculus things, whatever those things may be, will be easier to do it on a 1 than the expression that we started with here. All right, we're going to do some arithmetic review real quick, because we're going to use this, but with trig functions. So this is a complex fraction. I have a fraction within a fraction, and then a fraction in the denominator as well. So we just have to remember that that fraction bar just means divide. 2/3 divided by 4/15. So that's 2/3 times 15 over 4. And then we cancel, like we've learned in the past. There's 1, 2 there, 2 2's here. 1 3 there, and 5 3's there. So this turns out to be 5 over 2. All right, same thing here, b. We got 4/5 divided by 4/35. That's the same thing as 4/5 times 35 over 4. Right, and then we cancel. I know I'm going pretty quick through this, but this should be good review. Pretty simple review. We get 1 1 there. And then 5 goes into both of those. There's 1 5 there, 7 5's there. So we multiply, we get just a 7. Nice and straightforward. Okay, 2/5 divided by 3/5. And that is 2 over 5 times 5 over 3. Those 5's are going to cancel, leaving us with a 2 over 3. Okay, and then one little tricky one here. This is just 1/2 divided by 2 over 1, right? We can take any number we want and put it over 1. It's the same thing. And that's just 1/2 times, flip it over, 1/2. And 1/2 times 1/2 is 1/4. We just multiply straight across. Okay, that was a quick review. I know it moved pretty fast, but I'm just hoping that this is a review. Not the first time you're seeing it, but if it is, take the time, pause it, go over it. All right, so let's take a look. We have a handful of problems, I think 4 here, that are going to be similar to that those last 4 that we did, but now we're going to use trig functions. So the first thing I'm going to do is change them. Good rule of thumb always will be to change it to sines and cosines. So this is 1 over sine theta divided by cosine theta over sine. Okay, and then that is 1 over sine. And then we do divided by the bottom fraction. Right, and what we do is we keep the first fraction like we did with numbers. Don't overcomplicate it with the trig. Change it to multiplication and flip your second fraction. Just like we did with numbers. It's cosine. And notice now, just like the numbers, we have stuff that are going to cancel, and then we just multiply straight across. That's 1 over cosine theta, and that's just a secant theta. All right, I got to move this because I'm going to need the room. All right, so you can see how we're taking these complicated expressions and making them not so bad. All right, take a look here. All right, we have 1 minus cosine squared. We can change that right away. That is a sine squared theta over tangent. Now I'm going to go ahead and change tangent to sine squared over cosine squared. All right, so we get the top fraction, which is just sine squared theta, but I'm going to put it over 1. And then we're going to divide that by sine squared theta over cosine squared theta. Right? We keep our sine squared theta over 1. And we're going to times this by cosine squared theta over sine squared theta. Those cancel, and we get cosine squared theta. These two cancel, the squares. So we took this pretty complicated expression and changed it down to cosine squared. Those things are equal. Right? Problem C here. So we're going to get, I'm going to change everything to sines and cosines. So the top will be cosine theta over 1 times, that's going to be 1 over cosine theta, and then over sine squared theta. Actually, let's leave that for a moment. Let's see how that's going to work out. You can see that the top, cosine squared over cosine squared, right? The cosines are going to cancel, right? Leaving me a 1 over tangent. Well, 1 over tangent is the same thing as cotangent. Right, let's do problem D. All right, so I'm going to change everything to sines and cosines. So this is sine theta, over 1. And then the bottom is 1 over sine theta. I use the division, so it's going to be sine theta over 1 divided by 1 over sine theta. Okay, well I'm going to leave that as sine theta because you're going to see what's going to happen. I'm going to flip the second fraction, and I get sine theta, which is just going to leave me with sine squared theta. All right, so we're building up to what we're going to do is prove some identities are equal. But I would chunk it like this. I would take a moment, go over all of these again, and make sure you feel fine before going forward.